I put my wife's prescription Oculus Quest 2 lenses.
Yeah.
She liked it. I mean, well, she's very, she would use the word persnickety.
Okay.
So my wife is like, if she gets new glasses and it's made of the wrong plastic, she can't walk. So she's extremely sensitive to everything, basically. But she could see great, and she was having fun. She was doing hot air balloon rides in VR, in the YouTube VR, in 8K and 12K, and she was liking it, and everything was going great she was in there for like an hour and a half, and everything was going great until she ran into a Harry Potter Universal Studios roller coaster thing. She thought she was taking a tour of Diagon Alley. Was not that. It was pretty poorly taken VR, very shaky, jolting. Yeah, so she did that. And then she spent the next hour. I had to get her anti-nausea medicine, and she sat there with a bucket next to her. Nothing actually happened, but she was she had to recuperate. I think I got them from I think it's called VR Flow, maybe. Came from China. I don't know that there's any sort of massive reason why they're the ones I got. But they were pretty easy to put in. You just put this little cap thing on top of the lens that's already there, and it has like 3 magnetic contacts, and you just drop them on there to like instantly connects to it. They're pretty easy to take in and out if you like share the headset. But she didn't complain about it, so I would say that's a 5-star review. If she didn't say that it caused any sort of artifacting. So her last pair of glasses that she got, it's like 3 years ago, because we only take her back once an equinox, because we don't have to do she sent it back 4 times. They had like a micro scratch on it that you had to like put it under a microscope and get it in the right lighting to see, but she could see it. And I believe she could see it too, because she said it was there and they found it, but it required like very close observation with one of those like monocle, like, the microscope things. So she is highly in tune with the world around her. And then V put me into that dance game. That was stupid. I don't know, maybe 20 minutes or something. I mean, it wasn't like anything bad. It just wasn't any, like, the graphics and stuff were pretty good. I just didn't think it was. She said she liked it, but it was not something that I would have ever tried, which is a good thing. All right. All the screens. All right, so for today's homework, we are we're updating our let to work like a let star. Is that correct? Okay. Which means, so we don't need to change our parser at all. But when we go to our run parse code, it is this dude down here that needs to change, right? Because inside of our, let's see, is that our let stuff? No, yeah. Let expression, this guy. So we get our scope, or our new scope is from our construct scope, where we're passing it our catter of parsed no code. And is that the list of 2 lists? Yeah. So we're passing our construct scope, and that's got to be up by our variables. So that's the guy we need to fix, his construct scope. So this guy up here, he's taking in our list of two lists and the current environment. So this is the line we have to update. So let's show an example where it's not working first. So let's see, do I have a, well, we can just do this. A is 2, B is A. Go ahead.
I was gonna say if you pointed the example code you gave.
Is this the example code? Where's my, is it my example code?
I mean, mine's a B, but yeah.
Are you lying? Did I just give it to you in a slide or I put it in the code?
You gave me some stuff.
Oh, okay. Who? Okay.
It should give you the
Right, because B is equal to A is going to find this A. Well, it's going to give you a 7 actually, won't it?
yeah, no.
This is our sample let no code. So let's make sure this guy does what we want it to do. So there's our 7. So this guy right here, where we're creating a let, setting A is equal to 2, and then B is equal to A with the intent of having B equal to 2, the A we just set. But what it's actually getting equal to is the A from our global environment, which is a 7. All right. So we're making our let work like a let star. So we want this guy to update our environment to have an A equal 2. And then we want this guy to be able to find out that you just gave yourself a more local version of A to give us a 2 there. So we should get a 2 out of this instead of a 7 out of this once we have this done correctly. Okay. So up here in construct scope, we're taking in a list of 2 lists. So this is the, that list of 2 lists is going to be effectively that guy right there. Parsed, you know, into its format, but it's going to be that list of 2 lists where we have a variable name and then whatever its value is. So we are going to need to call run parsed expression, whatever we called it, run parsed code on the value there, but we want to run it. We want this guy to run this lit expression in the current global environment that we have. Then when we get to this guy, we want it to have access to this environment in progress that we have where this guy was just added to our scope. So we want to have the ability to kind of continually build up our scope. So we kind of have we have a scope in progress instead of one tendency you might have in solving this problem is you might try to create 2 new scopes. You might try to create a scope for A is 2, and then another scope for B is A. You might be able to pull the problem off that way to get a correct answer, but that's not the way languages typically work, right? If we are inside of a let, the result of that let is a scope, a single scope. So that's going to be a what we're going to try to do here. That was way too hot to take that big of a gulp. It's a good thing I have a calloused mouth. All right. Let's see. So we, in construct scope, this map here isn't going to work the way we want it to work, because what we're doing is we're mapping this function. And what does this function do? This function takes a single 2 list and creates a list out of the variable name of that to list and whatever run parse code does on that on the parsed code version of that to list, the second element of that to list in the current environment. And this guy is going to always map that same environment across there. All right, so we're not updating that environment. Let's see. Can I do this with a map still? I really want to. Okay. So what we need to do is we need to take into consideration that the result of applying, well, the result of this guy creating this new list that is the variable name and the executed secondary code in this environment should add into our scope and progress a new value for this variable. Could be the first time value for that variable, or it could be something that shadows the more global version. So ultimately, after this runs, our environment has been extended. And we want to make sure that the next to list that we process has the advantage of having the environment that we just modified from the previous guy. And the way I have it written right now, it's not going to do that because we are using the same identical environment for every single to list that's in that list of to lists, paying no attention to the fact that after the first to list, the environment is now potentially different. Well, it is different, but it might be different in such a way that it's now shadowed a more global variable. And we want that environment to be available to us on the next one. Okay, so we're not going to be able to directly map this guy across there. So we need to solve the problem of having a to list. Let me just draw a picture of this. So I'm going to have a to list, something like A lit exp 2 and B var exp A, something like that. And we want to have the benefit of a more local variable A being equal to 2, updating our environment so that when we execute var expression A, we get that more local version of 2. So we need to have our environment being updated as we're processing through this list. Okay, so that's probably going to involve recursive calls to our construct scope, right? Where we're giving it the updated environment each time. So we can dump this guy. And we'll go back to one of our old old patterns. So if null list of to lists then, well, that's the empty list. Missing a, no, we're good. If null this, so if I'm at the empty list, then boil down to the empty list. Otherwise, I have at least one to list that's in there. So I need to go ahead and execute the body of that guy. So we're going to, I'm going to put this inside of a let as we kind of let this grow. So let's do something like cur to list is equal, well, we've been doing something like that, right? Cur to list is going to be the car list of to lists. I'm just kind of picking out my variables so we have them more conveniently available to us. And because of the way I'm going to write this, I'm going to make this guy a let star. Okay. So there's my first variable I'm going to add. That gives me the two lists that I'm currently working with. Now I need to have, and I know that the body of this guy, that keeps happening. I wonder why that is. I have no idea. But I'm still alive on this thing just after today, after we're done, when I'm logged out. Yeah.
Are you signed into your phone?
I guess it's possible, but I don't think so. My phone restarts every night, so no. And I'm not signed into any of their laptop. I want to say that it must be like a Zoom issue right now. It's possible, I suppose. What was I doing? Okay, so we have our cur2 list, and maybe we can even say, well, I'll actually keep working with that just in case I want to have that to list. So we'll call this guy curvar is the car of cur2 list. I might not actually need all these variables. I'm just giving it to myself for convenience reasons as we write this. And we're going to say cur expression is the catter of cur2 list. All right. So these are the guys that I want to expand my current environment with. Now, I am going to be extending a scope here, right, with a list of vars and a list of values, as well as the current scope. So I'm going to be building up a scope here. Now, kind of the problem with this is we're going to, if we write it internally in here, we're going to make the assumption that the car of our environment is always a scope in progress. I would rather have an external function that kind of spells that out for us, but we'll see where we go with this. Because what's going to happen here is we are going to execute this guy. In fact, we could execute it right now. Our cur expression value is going to be our, what's the name of the run parse code? This is going to be run parse code on the catter of cur2 list in whatever that environment that was passed up here is. Presumably, I'm going to be calling it another time with an updated environment, right? Okay, so that's going to give us our value. Now, we're going to get her scope is going to be our it's going to be when I do construct scope, when I call that, have I already created an empty scope? I don't think so. No, I'm just passing it the environment. So actually what I could do here I'm going to call extend env, passing it. Don't I have something called the empty scope? Empty scope? Yeah, there it is. So when I call, I'm lost. This guy. I'll call extend env this environment with the empty scope. So that means when we get to construct scope, he's going to get the current environment. I think it was the environment first, then the scope, right? Extend ENV, nope, scope first, then the environment. So right here, I'm going to pass into construct scope my current environment with an empty scope. That is a scope prepared to be extended to my construct scope. That way I can assume that the car of my environment is my scope in progress. Does that make some sense? So I'm just preconditioning the scope I'm passing into, or the environment I'm passing into construct scope. I'm going to pass in whatever the current environment is with an empty list as its first element before that. So I have two scopes at the least. I have an empty scope and then the global environment the very first time I would call this. So what that then does is we get up to construct scope. I know that this environment here has a car whose that is the scope in progress. So that means the current scope here is the car of my environment. That's the current scope we're dealing with, which the first time through will be the empty scope. Presumably we're going to be extending that, right? So now I'm going to extend that scope. So new scope will be the extend scope with a list of vars, list of values. Well, I'm only going to extend it with a single var and a single value. So this is going to be the list version of curvar. And the list version of cur expression val. So I will extend my scope with this new variable that we just calculated in whatever the current environment is. All right, then I can create a new environment. Now you didn't have to spell out all these variable names like I'm doing, but I find it significantly less confusing to keep labeling things as you're going through it. So you can say, ah, this is what I'm dealing with here, and this is the guy that I need for the next part. So that means my new environment here will be and this is kind of what I was saying before, we are technically manipulating our environment a little bit based on our knowledge of how the current environment works. I'm going to write a function to do this. It's not going to be anything fancy, this function, but I want to put it in a function so that if we ever do change the structure of our environment, we can, we'll be reminded to update it inside of this function rather than having this random logic code stuck in the middle of this let star, which is stuck in the middle of a function called construct scope. All right, so I'm going to call this guy define. Let's call this guy update scope, because we're updating a scope in progress. And this will be a lambda that's going to take in an environment. And a new scope. And what he's going to do is he's going to return the list version of new scope and the cdr of our current environment. So peel off the, actually, we can do new scope. Extend scope. Where's my extend scope? Oh, right here. Thank you. List of vars, list of values, and the current scope. And I didn't give it that. Because I called extend scope right now. I gave it a list of vars and a list of values, but I didn't give it the current scope. So really what I want to do is I want to do this. I want to say update scope. I'm going to change the order of this stuff a little bit. Environment, list of vars, list of vals. And then this guy is going to pump out he's going to pump out an environment that is the environment with the current scope updated with this list of vars and a list of vals. So we're going to go ahead and say, how's my extend ENV work? I have a scope. Yeah, I like that. So we'll call extend ENV, passing it my updated scope. And my updated scope is going to be, I'm going to put this in a let per scope be the car of ENV. Let rest of environment be the putter of ENV. And then this stuff, what we're going to return here is a extend environment. What environment, or what are we extending it with? We're extending it with an extend scope. I'm going to put that inside the let. I like labeling stuff. This is new scope. New scope will be extend scope. Which scope are we extending? We're extending this scope with our new list of vars, list of values. Extend scope, list of vars, list of vals. I say vals or values, vals. And the per scope, that is the guy we are extending. So that will result in our new scope. So then our new environment will be the new scope extending the it's the old ENV. Extending the old ENV. That's what update scope will do. It'll take in the current environment, presumably with some scope on the front of it, a list of vars that we're going to be updating that scope with, a list of values that we're going to be updating that scope with. We'll go ahead and extract the current scope from the environment. This is where we're showing our knowledge of how our current environments work. We'll then also give ourselves the, a pointer to the old environment portion of it. Then we'll go ahead and build our new scope, which is just going to be extending whatever the current scope is with the new pieces of information that we're sent in here. And then this function will result in calling extend environment with the scope, new scope we just updated, and the old environment with this update, the scope in progress removed from it. So that's what update scope will do. So we do not need to call new scope here. Do I want that? I'm trying to decide if I want to change the name of this. Because I'm calling it update scope, but I'm returning an environment. Or update scope to ENV? Or do I just have it return a scope?
You have a way to resolve something.
Well, you can, but then I don't think you'd want to do that because resolve already takes into consideration it's looking for if it doesn't find it here, it's going to check the next place. This just comes down to a naming convention. Okay, I'm calling this guy update scope, yet he's returning the whole environment with the updated scope. He's given me back what I want. I just want to make sure I don't have a confusing name. Update scope.
I think we've talked about it enough now that we're not going to forget it.
Well, no, but that's kind of the point, is if you come back 3 years from now to make an update to the language, you want to know what your components are here. You don't want to make internal assumptions about how the environment works. So let's see, update scope. In Curry ENV. I know that's pretty verbose, but to ENV it's pretty bad.
We could just call it that.
Update ENV with scope in progress. I think that'll give us what we want. Because this guy is returning an environment. So that means we don't actually need we don't need this guy. So our new environment will be the update ENV with scope in progress, passing it our current environment. So I don't need the current scope here either. So the current environment is whatever ENV currently is. That's what was passed into this construct scope. And a list of vars. So that's going to be the list version of curvar. And the list version of cur expression val. So update ENV will take in the current environment, the list of vars, list of vals that we're going to be updating the environment with our scope in progress. It's going to peel off the current scope. It's going to also give us direct access to the old environment. And then we'll build our new scope, which will extend the scope of the current scope. And then we'll extend the old environment with that new updated scope, giving us a brand new environment with these new variables now tacked on, not a new scope. So then this guy's just going to boil down to our new ENV. Is that what construct scope gave us, or did it give us a scope? What is construct scope supposed to do?
I think it created the scope, but I think we had to
Well, but this is our builder for our scope. Let's see.
So I'll give you a scope, and then scope is just the two lists, so we'll put that in this one.
Right. I don't know if this is how I want it to be now. Because this is giving me, this is just a scope. And if I have construct scope, give me the updated current scope with that. Then my new environment operating off the current environment already has that old scope in it. So I don't want to extend my environment that has my old partial scope with this new updated scope in front of it. And I can fix it in here, but I don't, for the same reason, I don't want to lose the logic of it. So I'm feeling like do I call construct scope anywhere else? Magic? What did you just do? Oh, you can't just think about what you want your computer to do and it just happens? I copied the word, then I did a find. So on mine, it's Command F. For a PC, it would be Control F. And then I did a Command V to paste what I copied. That's just how this program does. Yeah. It's like, oh yeah, that works in email. It works everywhere. It's called mental pixel manipulation. Now the question is, how do you undo it? Who? This guy? Well, how did I do that with the keystrokes? You didn't see me click on anything. That's what made the other thing magical. All right, so this guy is going to be so I don't think we want our what am I calling construct scope with right now? That's the list of two lists. And then this is my environment with an extended scope in it. So if I pass this guy a list of two lists, so this guy's getting a list of two lists and my current environment with a scope on the front of it.
And so that current environment is the global environment.
In our and an empty environment if this was the very first time it's being called. And because of this name, the presumption would be that I'm going to be returning a scope. But I don't really want to. I wanted to return an environment. Struct scoped E and V. Take a list of 2 lists and the new environment. So with that in mind, I don't like the fact I'm going to do the same thing, but I don't like the fact that I'm arbitrarily throwing this empty scope in here. So if I come back here 2 years and I look at that, I'm like, okay, well, what the heck am I doing there? So it would make more sense for me to do that. Just make this the environment. And then up here, I'm going to turn this guy into a cond. We know that my environment will have at least one thing in it. Otherwise, it's not an environment because we're not resolving here, right? So if null tar env I don't know if I like that. Effectively, what I'm going to do here is I'm asking the question, if there isn't already an empty scope on the front of the environment, then throw an empty scope on there and recall this function. But do I need to do that here? Or can I just ask the question? Before I do that, let's just keep going down the rabbit hole here. So if my list of 2 lists is empty, just return the empty list because I'm constructing a scoped environment. So there's my current 2 list off of that. There's my new environment. So I'm not doing this quite yet. So then my that's in my else. That's fine. So I'm going to return construct scope environment on this guy takes in a list of 2 lists and an environment. So I'll say cdr list of 2 lists and my new environment. That's the environment in progress. I want to think about this for a second with my scope. So my new environment will be update environment with scope in progress, where I pass it the current environment, the list version of the current variable, and the list version of the current value. I need to make sure that let me draw a picture of the issue here. If I have an environment and right now I have my A is 2, B is 7, something like that. And I'm in the process of adding a scope. if the very first time I pass it this and I say, oh, let's go ahead, we're constructing a scoped environment in, we're doing update environment with scope in progress. If I pass it this, it's going to think that the scope I have in progress is that guy, when that guy's actually going to be my global environment. I need to make sure that if I haven't started my scope yet, I tack on that empty scope. So the presumption here would be is if this is the very first time I'm calling it and I happen to only have my global environment, I'm going to be passing it something like that. And when I say update environment with scope in progress, if this guy isn't at least a 2 list, maybe that's it. If his length is not at least a 2 list, I need to make it the empty scope in the first element. Because we can presume that we will always have a global environment, even if there's nothing in it. A global environment still exists. There is a scope that is our global scope. All right, I think this will get what we want. So let's see, I'm going to just say per env modified for scope if equal 1 length of our environment. If the current environment only has 1 element in it, then what I want to do is I want to boil down to extend env with my new scope, which is going to be the empty scope, and the current environment. Else, it could just be the current environment. This guy right here ensures that our env has a scope to update as its first element. So this is really just covering us for the very first time we're updating it. I'm making sure I tack on an empty scope onto the very beginning, and that's the dude we're going to be updating. So I want to make sure I use that guy in my update env with scope in progress, where this guy is either going to be that updated one, or he's actually just the environment. He's a synonym for the word env. All right. And then this guy will call recursively this construct scoped environment, passing it the rest of my list of 2 lists, as well as my environment in progress that has, well, my current environment, which has a scope as its first element, presumably in progress. So now I'll come back down here and where I run my code. I no longer need either of these variables, right? Actually, let's get rid of the new scope. List of two lists. I'm going to give myself that, a variable called that. So that's going to be my new list of two lists. And then my new environment is going to be the result of calling construct scoped environment with my list of two lists and my current environment. That's what he takes, right? That order. List of two lists and an environment. So that will be my new environment. This will be the body, and then I'll run parse code on the body in that new environment. I think that should be it. So this guy used to give me a 7, but it should give me a 2. Did I not? Oh, thank you. It didn't find the 2 though. Ruh-roh. Well, let's see what this guy's looking like coming out of there then.
I found that if you go to where you do the expression inside of run, if you get rid of that line and just put this way,
Yeah, that's what I was gonna do. Yeah, I just wanted to see what he looks like for the moment. So I'll remove that for a second. Let's just see what our new function is building for us. And that should give us a picture of maybe what's the issue. Beautiful. That is yeah, so correctly, it didn't find crap. It didn't find anything in there. All right, so let's let me make sure I'm giving it the right stuff then. That's definitely surprising. My list of two lists. Let's make sure that guy's the right thing. List of two lists. Just make sure we're getting the right stuff out of that. Okay, there's a list of two lists. That part's good. Okay. We just saw what the new ENV looked like. So let me just take a peek at the current environment. That looks like correct. That's our global environment. Everything's good. All right, so it is our new ENV that's coming out as the empty environment. Okay, so we know the problem is in our construct scope ENV. We know that this guy is our list of two lists. We know that this guy is correct. So we know that these two parameters being passed in are correct. So I'm guessing it's something with my recursive call here. Okay, so if it's null, return the empty list. Fine. Oh, I need a cons. Well, I don't need a cons. I just need to make sure that this guy is ultimately ending. Oh. We just spit out the environment that we've been building all along. Once I run out of crap, I need to say, here's your environment. Instead of just like saying, look, I've done all this work. There you go, empty list. I'm not giving you squat. All right, this guy should give us a much better looking environment now. All that work, we just threw it out the window at the very end. It's like, look, I did everything right, but I'm not giving it to you. You do not get this. Yeah, I did everything. I had everything. You know, it's like, here's your updated scope. Everything looks beautiful. But the very last time through, like, oh, you're done with lists of two lists that you want to expand your scope with. Great. Okay, I've done all this work. Here's the empty list. Resolve your variable in that. Well, I didn't have to comment on. I'll just show you what it was before.
Oh.
Yeah. When I ran out of 2 lists to add to my current scope, I just said, yeah, here's your new environment. Every single time I'm giving you an empty environment. I don't care what you give me. You're getting an empty environment back. That's it. I probably want to give it the environment I've been working so hard to build. Well, I need to go and add that line back in. It'll work now. Oh, see, it's always like the stupid thing you do. Yeah, so I mean, if we run this right now, we're going to get the correct environment out of it. There's that guy. So now we need to run parsed code in our new environment, and the code we're running is the body. And this guy should give us a what? 2? Or is there 2? So technically it did give us the right environment, or right answer. It gave us the run parse code of the body in the empty environment. That answer is false. That's what you're going to get every single time if you don't have variables. Okay. Well, now, so what's interesting about that? I mean, we were pretty verbose here, right? I just like creating lots of little variables. Isn't this just as complex as the map? So it's easier to understand. Although this is actually an interesting example for not a weakness of map, but when is map the correct tool for a job? Because in this particular case, we have we need that value that we're passing through with the map. We need that guy to be updating, and that pretty much disqualifies map for an appropriate solution because of the way map works. Map says, look, I'm going to take this and I'm going to map it across every one of these elements. If you need this to change after I've done it to one of the elements, map's the wrong tool. Make some sense? Okay, so map is great for situations where you want to do the identical thing to every element of a list. But if you want to do the identical-ish thing to every element of the list, it's not going to be the right tool. If you need things to update in between, unless you had a global variable. So in our case here, we could have still done it with map. It's not the right tool for the job, but we still could have done it with map by giving ourselves a global variable for our environment and updating that along the way. But that's not the scheme way of doing things, where you have variables that you update then reference back. We're passing things as they change, we pass them through recursively. Go ahead.
So what's the problem with each separate unit?
Talk about in here?
No,
No, in here.
Instead of creating a single.
Oh, I understand what you're saying. What you did is, in this particular case, so where's our code? You had a scope. So you actually ended up with 3 scopes. You had the global scope, then you had a scope containing just A is equal to, and then you had a scope containing just B is equal to A. So you bypass this idea of having to update it by just saying, new scope, go. Well, first of all, we can start off by just saying that's not the way languages would typically work, but that's not a good enough answer, because now we got to decide, is there actually a problem with doing it that way? Does our variable resolution have to all exist inside of that single scope, or is it going to be a problem for us to go down? I think when we come out of a call, we're already popping to global, right? So in your case, you added 2 scopes. In my case, I added 1 scope. So my 1 scope had 2 elements in it. You had those 2 elements spread across 2 scopes. To undo that local scope, local scopes situation, we're still going to pop the global. So yours would reset correctly. Mine would reset correctly. Is there a downside?
Because yours was a lot more complicated than mine.
Well, right, because you use tools we already built. You just like, hey, new variable, extend the scope, extend the environment with this new scope. Yeah, absolutely. I get it. I get it. So, you know, mine literally took into consideration that the variable that we just did might be done in terms of another variable in the current scope. And that's the way we would certainly think about programming languages, in that, hey, I'm inside of a function, and things that I update in here, if you say int a equals 2 and then int b is equal to a, the presumption is that those 2 variables, a and b, both belong in the single scope that is associated with that function. Now, but having said that, just because we mentally consider them to be part of the same scope, behind the scenes, it doesn't necessarily matter. Is it a problem to say that, look, we're going to represent those variables in whatever way we're going to do? You don't need to know. It's going to be what it's going to be. Just know that your values will be okay. So what I'm searching for here is there a situation where yours would break? Yes, I mean, my initial thought was that it was going to be the clearing the extended scopes once we go back. But we're good there because of the way we implemented pop to global. It's like, look, you're adding new crap, now you're going to go back to the old crap. No problem. We're just going to dump everything that we've had. Because it would be a problem if we ever had a situation where we just say, hey, let's just peel off the most recent scope. Because now the most recent scope isn't actually, in his case, the most recent scope. It's the most recent piece of a larger scope. Go ahead.
It would be fine, because at least how I implemented it was I returned the new scope and just using like the impasse of the old document, and that constructed the new scope or the new environment. So whatever I do to be inside of construct scope,
Yeah.
Like I just did it within that scope of constructing or construct scope and didn't use it elsewhere.
So you had a special function
So
specifically for dealing with scopes related to LETs?
yeah, so construct scope, that was only for scopes containing to let's, right? And so in there, we just kept adding a new scope every time we hit a new variable. And then at the end, I cons all of the scopes on to each other to create the new scope and just return back.
There, just so everybody can see what we're debating here. So Jason's version of this is, let's see, you would have had A is 2 first. And then he would have had B is A second, which would have resolved to 2. Yours would have looked like that. So that's Jason's version of this. When you had this code, he actually effectively extended his environment twice.
Both of those two, B2 and A2, are also in each of those.
Yeah, sorry. Yeah, same idea, but yeah, this is the correct way of writing it. Here is the global scope, although this is a, oh, that already had its extra set of parentheses. It was a list containing, oh, wait a minute. So this guy should also be in an extra set of parentheses.
Because global, it also already is.
Oh, it just looks weird because of the word global in the front. It's still, it already is the thing. Okay. So this has 3 scopes in it, the global scope, this halvesy scope, and this other half of the scope. So this is what Jason's looks like. Mine looks like that. So mine has the first scope being the fully realized scope, but that was built in terms of things left to right. So the issue is that when we look at these two, this one looks more like the way we think about scopes. Jason's question was, is there anything wrong with representing these 2 variables in separate scopes, knowing that we're going to hit this scope first, then we're going to hit this scope. It is reliant on the order in which we, how we extend our scope. But that's how it works now. So it's not a problem. So in his situation, if we run into B first, we'll get the right answer of B is equal to A, because A used to be 2. So when we go to resolve that, when he was building this scope here, he said, oh, we're going to look for the value A in that environment. And he's going to find A right here instead of this more global A there. So he got his 2 out of there. So what we're searching for here, is there a scenario where this would actually backfire? I don't know if I can come up with one. At least not off the top of my head. I mean, everything, it definitely looks weird because we are just creating 1 new scope. So, but in this case, you're creating 2 scopes, but nobody has to know, right? That's happening under the hood. So the programmer's like, hey, look, I created 2 variables. This is I made an int A, set it equal to 2. I made an int B, set it equal to A. It worked. Everybody's happy. The fact that he represented those guys as 2 completely separate scopes. Let me go down to like a for loop. If we throw a for loop later on in the code, which will then get its own scope.
Turns out I did it wrong.
Okay, I said
A lot simpler though.
Well, was it actually simpler, or did you just not use all these extra variable names?
It's like, I don't even know.
Because really mine looks arbitrarily complex just because I listed out a zillion variable names, just so when I got down here, it was easy only for me to return the empty list.
I don't know, I really feel like mine should be what I'm always saying.
That's what mine is. I'm so curious.
So you thought yours should have done what I have.
Based on how I understand it, mine definitely should.
So this is really Emily's solution. And then this is Jason's solution, which looks like mine. What's up? Oh, is yours different?
No.
Oh. So I can't necessarily find fault in it. It's weird from a thought process perspective, but it's only weird from a thought process perspective is because of that's the way I've viewed scopes. It's a collection of 2 lists. That's what a scope is. We're adding 1 new scope. why do you have two? Other than it just being weird, but it's only weird in the context if it's is in the context of me not thinking about it that way. It maybe is a little inconsistent because it's weird that you have separate scopes here, but why isn't the global environment set up as separate scopes? But it's easy to just say the global environment's a special case. We've already labeled it as a special case, so I don't know if that's a problem either.
Could you print out up in the other question? Could you print out the new file?
In the run, so you want me to, instead of this guy, you want me to print out new EMD? So there's the list of two lists, B and A. And then there's the list of two lists. That's my global environment. You said yours has an extra empty list somewhere? Well, that's a zero.
I have it on call first.
That's a zero. I mean, at least Emily's is weird, but right. Well, I assume it's right. Well, it works. It works doesn't mean much. All right.
My sample web code also has calls.
Yeah, so if we assume, going back down here, if we assume that this solution, that if we assume that that resulting environment that we're running our code in for a let star, if we assume that that's acceptable, and we can't necessarily, I mean, I haven't found, it's weird, but I can't find a fault in it, then this was an overly complex solution because you could just use the tools that we already had to just keep extending environment with a new scope. It just so happened that your scopes were just one variable long. Not the end of the world. You know, you're using the power tools. So yeah, I mean, I think that's reasonable. I still like visually this one better, but I don't. I think that's just ingrained thought, not necessarily because it's has to be that way. I really feel like there's got to be something that this is going to be a problem.
I'm sure down the road we can probably find one, but in our current.
No, I agree. I'm kind of thinking that at some point we're going to bump into something. We're having what's really a single scope separated into pieces will be a problem. But even with that being said, well, this probably isn't fair either. You could have, in this case, it probably makes some reasonable sense. If you only ever added one extra variable, it would break. But here you could have just gone back and post-processed your environment and just merged those single two lists back together into a single list of two lists and gotten this result from it. But that's probably fraught with danger as well. Interesting. Yeah, well, I mean, but that's all good discussion. I mean, it's this really does come down to language design. You know, this version of it takes in the traditional thought of scopes, but this was easier to implement, and what's wrong with it? Yeah, I don't have, I mean, I can't find legitimate fault in it. All right, so I'll post this up. So this is working let star. Note the potential different approaches in the Emily/Jason variables. This code works like Jason, but Emily code was significantly shorter using tools that we had already created. Okay. So we'll come back on whatever day it says, Tuesday. We'll come back on Thursday, and I think we might do begin expressions actually, so that we can have a list of things in a row that potentially change the environment. But we'll see. We'll see what the hell the spirit guides me. All right, so no homework for Thursday.